All right, so we got a couple of good ones in. Let's see what this one is about. I haven't used the screen command yet. Linux has a wonderful tool that allows users to run multiple terminal sessions at once in the same window. The screen command can be used to switch between different terminal sessions, all from one terminal prompt. In this lab, you will use screen to create, connect to, and disconnect from existing screen sessions. All right, very cool. I haven't used this one at all. Alrighty, so what do we have here? Got a bunch. Screen is an incredibly useful tool for system admins. It allows multiple terminal sessions to run at the same time without needing to be closed down. It's particularly beneficial as, unlike the standard terminal window, it will allow you to resume a task. Huh. Let's try this out. I'm curious about this because I could do, I could go like this, right? Okay. All right. So why don't we just use multiple terminal windows? Well, if you're using multiple windows, what happens if you accidentally disconnect from the system you're interacting with, or you accidentally hit Control-C? Any programs or processes in progress will be exited, and you'll have to start the whole process again, which could be hours of effort. That doesn't really sound right, because if I have processes that are running, that they continue to run on the server, so I'm kind of curious what they mean by this. With screen, if that connectivity drops or you accidentally hit Control-C, you don't lose your progress. Huh. All right. Screen H. To run the screen tool, simply type the command screen, add the H flag to. All right. Let's see what we got here. Man screen. Screen H. All right. So I don't have it in WSL. It might be like a real distribution thing. So let's try this out. Screen. Exit. Okay. Exit. Oh, let me do this. All right, so yeah, I'm kind of confused what we got here. Resolve host names only to IP6. All right. Okay. All right. Let's see. Onwards. If you want to see if any screens are already running, you can use the ls command with screen to list them out. Screen, let's see this, screen ls. Wait. Screen ls. There are screens on. Wow, okay. Screens on. Use the screen command to list all existing screens on your terminal. How many are currently running? 3, right? Currently running is 1, I guess. There are screens on and 1 attached. I mean, 1 is attached, 1's running, right? So let's see. Nope. Okay, have another look at the commands overview section in the briefing to help listing the current. Okay, so attached and detached doesn't matter as long as they're running. Oh, is this like the current screen that I'm on, maybe? All right, I don't know. I don't know. Interesting. All right. Multiple wrong answers. Screen ls, there are screens on. Is it because I'm in? I think that's why. Screen ls. Yeah, I think that's why it was. All right. That explains it. So I guess when you're actually in it, screen ls, you're actually in one of these All right. Creating and naming a new screen. To create a new screen with custom defined name, such as S parameter, because otherwise I guess you get this one, right? This would look like screen. It's useful to have descriptive names for the screens you create, making it easier to recall each one's. All right, screen S learning, screen LS. I wonder what this number is. What are the first 5 characters of the token you get when you successfully connect? Connect, okay. I don't know. Connect to an existing screen. So, how do you disconnect? Detach from a screen, Control D. Control D is Control A followed by Control D. All right, Control A, Control D. Screen LS. Okay, I could have just typed exit. All right. Let me go back here. Let me go back. Connecting to an existing screen, you can connect to an existing screen using R followed by the screen name. For example, to connect screen 1. It's handy to list out already existing screens first, just in case if your name hasn't been specified. Screen will create a default name for it, and they're not always the most pleasant to type in. Huh. Okay. Screen R token 1. This is a token. Okay. Very weird. Use screen to connect to the token 1 screen. Does that count as it? Okay. What are the first 5 characters of the token? Detach, we did that. That just exits out. Right? To detach screen, you press those. This will return you to the original session. Detaching from a screen simply removes you from using that screen and back to your original terminal window. It doesn't end or kill the screen session. Oh, okay. Killing screen sessions to completely kill, not just detach the screen. You need to Konami code the keyboard. Press Control A on your keyboard to remove your cursor from the screen's command line. Next, press K, the K key combination. Screen will prompt to confirm that you wish to kill. What? Screen R or screen hello world. Wait. S screen hello world screen ls. Okay. Control A K Y screen ls. So that one's done. That one's gone. Detaching from a screen simply removes you from using that screen, right? All right, what are the first 5 characters of the token you get when you successfully connect? Oh boy. All right. I don't know. I actually don't know because I deleted it. All right, let's see if that'll reset it. Let's reset it. Any submissions will be saved, but the machines will revert. Yeah, that's nice. Okay. Your hands travel at average. Wow. All right. Screen ls screen R token 1. First 5 characters, right? Boom. Which of these commands will create a new screen called MyScreen? MyScreen. Use the screen to detach from token 1. Now create a screen named Bob. I guess they want to use Control A, D, right? Detached screen ls. So those are good. Wait, so if we did this and we just did exit screen ls. So exit is like killing it actually, not detaching it. Sorry, screen ls. Exit actually kills it. Okay. Create one called Bob. Use screen to detach from Bob. What is the token you get when you successfully detach? Control A, D. Detach. That's the token we get. What is the token you get from successfully killing token 2? Do we have to go inside of token? Okay, I think we have to go inside. Screen R token 2. Control A, K, Y. All right. I don't know. I've never used this before. I'm going to, I guess, try to use it in the future outside of WSL, but obviously that's not going to work here. Actually, let's check this out. Screen command in WSL2. Running screen with that. Okay, let's see what we got here. Oh, because I guess, I don't know if it's graphical or not. The networking subsystem in WSL2 is different. You must consider the differences. All right, we're not going to get into this. I'll try to figure that out, but 14 of your 3 labs for this week. Yeah, all right. I guess you're supposed to be doing like multiple of these concurrently. But we're going to see if we can do all these in a row. Generating file hashes, combining commands. All right, let's do the file hashes. Let's try. So file hashes are fixed bit strings generated from a file and can be used to confirm the integrity and authenticity of said file. This can ensure that a file hasn't been replaced or modified from the original. All right, that's recognize hashes and how. Okay, this is good. This is interesting. All right, a lot of reading. All right. What is hashing? Hashing in digital terms is the one-directional process of converting a string of characters into another value using a hash function based on cryptographic algorithm. The result of a hash function is often called a hash value, or shortened to a hash. This data is always unique like a fingerprint and is often a combination of letters and numbers. Hashing is used for file verification, password storage, and sometimes database searching. It's commonly used to prove the integrity of copied or transferred data to reassure the recipient that the data hasn't been compromised. Changing a file, even by simply removing a single character, will drastically alter the hash of a file, whereas a duplicated version of a file would have the same hash regardless of its file name. Okay, so it's the contents. You can generate hashes via the command line to ensure that no files have been modified or tampered with, especially if they are sensitive. Okay, all right. Then many ways of hashing. There are many types of hashes that can be generated for files. For the purpose of this lab, we are focused on 3 basic hashes: SHA-1, SHA-256, and MD5. SHA-1 produces a 160-bit hash, so 160 bits. Let's see, actually, like, let me do this real quick here. Do this. Nano hashing. Just gonna put that in there. Yes. Come on, where am I? CD nano hashing. Drop that in. WC hashing. 141. 41 characters. How do we get the bits? WC hashing. 41. All right. That's 40 characters. Wait, what? Nano hashing. Oh, because of this one. Nope. Not sure. All right. An empty file called example would result in the hash. Okay. Produces a 256-bit hash value expressed as 64 characters. The same empty file called example would result in this hash. And just so I'm like, okay, let's do 64 times 64. No. So, all right. I'm not even going to go down that route, but the same empty file called example would result in this hash. Produces 120, MD5 produces a 128-bit hash, expresses 32 hexadecimal characters. The example file would result in this hash. All right, so this is obviously, this is shorter than all these other ones, right? Or hex is actually multiple. Hashing in the CLI, hashing files in the CLI is easy. Choosing the file and the hash functions you'd like to use, and you're ready to go. To use SHA-1 hashing, you would enter SHA-1 sum, SHA-25.6 sum, MD5 sum. All right, sounds pretty simple. Types of hashing: to check whether a file has been modified or tampered with, use the same process of generating a hash to check the hash. If you'd like to know more about hashing and encryption, you can check out the Introduction to Hashing Lab. You're not licensed. Ah, come on, man. That is bogus. Yeah, give me access, guys. What? All right, generates the hash for file. Let's do the command line. It's getting late. All right. In the terminal, use the MD5 sum tool to generate an MD5 hash of the file, not an admin, for the first 4 characters of the hash generated. In your terminal, use the SHA-1 sum. SHA-1 sum random. We're the first 4 of this one. Boom. Let's use the SHA-256 sum on that admin. First 4. So I mean, we got, yeah, from shortest to longest pretty much, right? Use a text editor such as Nano to open not admin. Change the file so that it reads the answer use md5sum on not admin. And what are the first 4 characters? So this one changed completely, right? Like, totally changed. All right. Interesting. Interesting. I like it. All right. What's next? Let's see what's next here. So file hashes. Let's do combining commands. We'll leave the last one. So it's possible to link more than one command together in the same line of the CLI. This makes it easier to run commands in quick succession or even simultaneously. In this lab, you will learn the different ways of combining commands within the terminal. All right. All right, good, good, good. All right, combining commands. This is actually pretty useful. An extremely useful component of using the Linux command line is the ability to string multiple commands together as one, often used when you need to take the output from one command as input for the next. It allows commands to be run in quick succession and at the same time. I feel like I've been doing this the entire time, but all right. Common operators are used to chain commands together. Each operator has different functions and will determine how the command is handled and the output received. Below are some of the more common operators used to chain commands together. Logical AND. Using this will execute the second command only after the first command has executed successfully. That's key. For example, if X gets the thumbs up, execute Y. If X does not get the thumbs up, the commands without running end commands. Okay, yeah, that makes sense. So basically, they both have to run. Or not both, but the first one definitely has to run, right? Logical OR. This operator will execute the second command only if the first command was unsuccessful. Oh, interesting. For example, if X gets a thumbs up, don't execute command. If X gets a thumbs down, execute Y. Interesting, interesting, okay. Which of the following operators would you use to execute 2 consecutive commands regardless of success? Regardless of success, okay. Semicolon, any command put in after the semicolon operator will execute regardless of whether the one before was successful or not. For example, if X gets a thumbs up, execute Y. If X gets a thumbs down, execute Y. There we go. All right. Pipe. I use this one a lot. The pipe operator is used to take the output from one command, so standard output, and use it as the input for the next, standard input. For example, execute X first and the result of that in conjunction with command Y. So this is basically, this is why I like doing this. So like if I do lsla, pipe it into grep, and look for comb, it'll find that, right? So, because otherwise I would have to do like grep comb and then a file name or something. But I could do probably this. I don't know if I could do that actually. Yeah, I can't do that. All right, I can't do that. I wonder if I could do, let's do this, SLA, something like that. Ambiguous redirect, okay. All right, background. When used after a command, this operator will send that command to process in the background while running the second command in the foreground. For example, execute X. Whoa. Okay. Interesting. Which of the following operators would you use to execute 2 commands where the output from the first command is used as input for the second? Pipe. All right. Which of the answers best describes what will happen when running command logical AND? So this one is going to run, and then this one's going to run. If this one doesn't run, this one doesn't run. So run command 1 and then command 2 regardless. Nope. Run command 2 if command 1 succeeds. Yeah, that's the one. All right, move to the combining commands folder. Let's move there. Did we go over this? New file. Now that's interesting. Why is it? Okay. Why are we doing this one here? Commands overview. Like, isn't that in the last lab? That's weird. All right. Yeah, let's move into the combining commands folder. Search the countries file. So search the countries file for all countries containing the letter Y. Right. So we're searching countries, right, for the letter Y. What am I doing? I always do. I always read searching and like instead of just using grep or something. Okay, cd combine, right, and then what are we doing? We're doing grep countries. Sorry, we're grepping. What are we grepping? Y countries. Okay, sort the output. Okay, sort the output to a file called output. Output. Token will be displayed if this is done correctly. Okay, this was done incorrectly. Sort the output of this command in reverse order. That's why I did. Reading comprehension, R. There we go. Reverse order. Boom. All right, move to the combining commands folder. Search the countries folder for countries containing Q countries. Write the outputs to a file called output2 and generate the MD hash. Okay, MD5 sum. Is that going to work? Or do you have to pipe it? You have to pipe it, right? I think you got that. Okay. What are the first 4 characters? Let's see if that's good. Nice. All right. All right, so the next one seems like it's going to be like a test or whatever, so I'll leave that for the last video. And let's see what we got here. Let's see what we got. Pretty good. All right. See you guys later.